Hello tribe, welcome into the second topic of the final exam preparation sessions. In this topic, we'll be talking about the first part of the patterns, sequence and series. Now if you're new to the channel, please be sure that you subscribe so you won't miss when another video gets uploaded. So without further ado, we're going to start with the first part of part 1 of the pattern, sequence and series. Now in the first part, we're given question 2 type of questions that you will get on your paper 1 final exam. Now here we have 2.1, 2.2 and 2.3. So let's go ahead and answer those questions. Now in 2.1, we are given the following arithmetic sequence. Now whenever you are given a sequence, it is important that first what you do is you write down the sequence arithmetic, and then you write the terms that you're given, right? Now, after you've written down the sequence, what's the first thing that you need to do? The first thing, since we know that this is an arithmetic, we're gonna find what? The constant difference. Now here, -4 minus 11 gives us 7, and this means this is also 7. Now here we then see that D is going to be 7. Now here, what about A? So here we know that A is the first term, so now here the value for A is going to be -11. So now that you have decomposed everything about the sequence, you can now go into into the questions. Now the first question, 2.1.1, it says let's find the general term in the form of Tn is equals to Bn plus C. Now we know that this is an arithmetic sequence, so an arithmetic sequence, it is A plus n minus 1 d. So this is the general formula for an arithmetic sequence. So what we're going to do here, we're going to substitute the value for a and also substitute our value for d. And then what do we do after this one? We're going to simplify. Now by simplifying here, this is what we get here. We're going to get 7n minus 18. Now as you can see here, this equation, it is in that form, so this is our answer. Now let's go ahead and look into the second question. Now in the second question, they say here they want us to have the value of the value of the 60th term. Now the second question says determine the value of the 60th term. Now here we do have our formula, so it's Tn equals to 7n minus 18. What else do we have here? We also have n as 60, because you know that the position here is a 60th term, but you need to know now what is the value on that 60th term. So to do that, we're going to say T60 equals to 7, and then we're going to substitute the value for n, which is going to be 60 minus 18, and then press this on your calculator, and then you're going to get 402. Now let's look over the last one, 2.1.3. Now 2.1.3, it says let's find the sum of the first 60 terms. Now here we know that here the first term of this sequence was -11. Then now the value of the 60th term, which is in this case now is going to be the last term, is what? Is 402. So now to calculate the sum of the 60 terms, we're going to say Sn equals to n over 2 into a plus l. L means it's going to be the last term, because remember here we want to have the sum of the first 60 terms. So we know what is the first term, we know what is the 60th term, which is 402. So now, which means now S60 is going to be 60 over 2 into -11 plus 402, right? Then now what we're going to do here, we're going to press this on our calculator, and then pressing it, you're going to get 11,730, and that is going to be our answer for this question. Now let's go ahead and jump into the second one. Now 2.2 says hence or otherwise write -4 plus 3 plus 10 plus ... plus 486 in sigma notation. So now what does this mean now? So it means now we need to represent this series in a sigma notation. Now a sigma notation is this symbol, and then inside this symbol we need to have the general equation for what? For the arithmetic sequence. Now, why am I saying it's for the arithmetic sequence? Remember, the question says hence. So the minute the question says hence, it means now we already discovered this sequence here. As you can see here, this sequence here with minus 11, minus 4, and 3, but now in the series, instead of starting with minus 11, you started with minus 4 plus 3 plus 10. Now, what does this mean? It means now here we already have Tn here, and Tn is 7n minus 18, right? But now here what they did was they wanted us to start in term 2 up until term of whatever this position is. So now, which means now what we're going to do is we're going to find out what position this is. So to do that, we're going to substitute the 486 equals to 7n minus 18, right? So now we're going to say 486 plus 18 is equals to 7n. Now when you press this on your calculator, you're going to get 504, which is going to be equals to 7n. When you divide both sides, you will see that 72 is equals to n, right? So which means this value here is T72. Now what are we going to do now from here? So what we're going to do from here is we're going to write this equation, or this series rather, in a sigma notation. Now in sigma notation is going to be the sum of Tn, which is 7n minus 18, from n equals to, now remember, minus 4 is the second term, so n is equals to 2 up until n is equals to 72, and now this becomes our answer. Now let's go ahead and look over the last question, which is 2.3. Now the question says, this arithmetic sequence forms the first three first differences of a quadratic sequence. Now the question is, which term in this quadratic sequence will be the smallest? Show all your calculations. So now here they're saying that we have a quadratic sequence. So let's go ahead and write quadratic, and this quadratic, we don't know what? We don't know its terms. But what we do know is that its first three first differences are minus 4, minus 11, minus 4, and 3. So now we already know that the difference here is 7. So now here the question is, which term, right, in this quadratic sequence will be the smallest, right? Now here we're talking about the quadratic pattern, right? Now we know that the quadratic pattern in general, its Tn is equals to an squared plus bn plus c, right? Now because of this is quadratic, to understand when the value is the smallest or the biggest, we always look at the value of a. Now if a is positive, it means now our value is going to be what? It's going to be smallest, right? And if a is less than 0, it means the value for n, right, we're going to have a term which is going to be the largest, right? Okay, so here, because of we have a quadratic, which means that biggest number or that largest number, you can only achieve it when n is equals to minus b over 2a. So this is the term where we have what? We have the smallest, right? Alright, so now what are we going to do now here? So what we're going to do is we're going to use this information that we have here. So the information that we have here, we have 7 as the second difference. So we're going to say 2a is equals to 7. So if we divide both sides, a becomes 7 over 2. Now as you can see here, our a is what? Is positive. So which means now we're expecting what? A smallest value here. Alright. Now what about b? Now we're going to say now 3a plus b is equals to minus 11. So now this gives us 3 into 7 over 2 plus b is equals to minus 11, which means it's going to be 21 over 2 plus b equals to minus 11. And then if you take that over, you're going to get the value for b, right, as minus 11 minus 21 over 2, which will give you minus 43 over 2. Now what are we going to do here? Now what we're going to do is we're going to say now n is going to be minus, then we're going to substitute the value for b here, right, which is minus 43 over 2 divide by 2, into what is the value for A? 7/2. Now if you press that on your calculator, what you're going to get is 3,07. Now 3,07, as you can see, it is close to and is equals to 3, or it is approximately and is equals to 3. And then now this is the answer. Now if you like this video, please be sure that you don't forget to subscribe so you won't miss when the second part of the part 3 series gets uploaded. And I'm gonna see you on to the next one. Cheers.